Welcome, guys. We have question two. Question number two here says that if w is equals to 5x squared plus y squared divided by z plus 1, so find the w and approximate this expression we have here. So the best solution to this is that at first we have to start with the definition, which says that um, trivially looking at this, we can decide to say that w is equals to a function in terms of x comma y. Um, that is, I can easily tell you that the function given to us here is a function in terms of x, y, and z. Do you agree with that? So that is the whole of this expression, this fraction. You can see that this dependent variable is actually based on three independent variables. That is x, y, z. So it's a function in terms of x, y, and z. So since we have this by definition, then it is clearly seen that the total derivative for the dependent variable we have over there, which is dw, will now be defined as um, fx dx. Since we have three independent variables, we have x, y, z. Then I also have fy dy, and at the same time, I will still have fz dz. Since I have three variables in the function, three independent variables. So now, since we have this, the main issue now is that we need the x, we need the y, and also we need the z. But here it is clearly seen that we only have um, this value for x, which is minus 1.98, 0.97, and 1.03. But initially, we don't know the points for x, y, and z from the beginning. But all we just have is this final point for x, y, and z. So we can decide to make a relation to something like this. Let's try to adjust the point given to us here. To make an adjustment to this, such that we can approximate this expression we have here using um, this point. You know, I just have to make some slight adjustment here, just slight adjustment, just like the previous example. That is, from the previous example, we actually have. Let me show you guys. On previous example, we have 3 initially. Now there's an adjustment to 3.05. But let's say we actually have an initial point for x here to be, let's say we have it as minus 2.0, which later reduced to minus 1.98. So let's say we have minus 2.0 in this case. And at the same time, let's say initially this thing here was 0.9. And at the same time, we have 1.03. Let's say we have it as 1. So we can decide to find an approximate value for this. So we can decide to state that this was the initial x naught value, y naught, and for z naught, and this is where it ends, which is x1, y1, and x1, and z1 rather, z1. So that means if I want to find the x simply implies um, the final minus the initial, right? Which is minus 1.98, then minus 2.0. At the same time, the y simply implies the final I have there, which is y1, which is 0.97, minus the initial guess I started with, which is 0.9. And at the same time, the z will be equals to 1.03 minus the initial guess for z, which is 1. So each of these, after subtracting this, we end up having, if you subtract this will give us 0.02, and this will give us minus 0.03, while this will end up giving us 0.03. So you can decide to form your own initial guess, but at least just try to create an initial guess, then you find an approximate for this expression. So now I have my dx, dy, and dz values. So the main work here is to find fx, fy, fz, where fx is the partial derivative of this function with respect to x, and partial derivative of this function partially with respect to y, and like that. So the w in this case simply implies that fx is not yet known, but I have gotten an answer for dx from my initial guess, which is 0.02. And at the same time, fy is not known yet, but I know the value for dy. Dy is minus 0.03. Similarly, fz is not known yet, but I know what the z is from the initial guess we've just introduced, and that is 0.03. Now the main work is, how do I find fx, how do I find fy, and how do I find fz? So um, take note of this. To find fx simply implies differentiate that function, okay, partially with respect to what? With respect to x. Differentiate f partially with respect to x. While fy simply implies differentiate that function partially with respect to y. And at the same time, fz implies differentiate f of xyz partially with respect to z. Now, to work with this simply implies that you have del over del x. What is your f? The f is in terms of xyz. Hope you know that that is what we actually introduced. W is equals to a function in terms of xyz, and that function in terms of xyz is what we have here. See it here, the whole of this expression. So that means I'm trying to differentiate partially, differentiate f partially with respect to s. And what is our f? Our f is 5x squared plus y squared over z plus 1. So if you want to differentiate this thing partially now, remember that I'm trying to differentiate partially with respect to s. And this thing simply implies, since you have a fraction here, so you should know that whatever rule you have to apply is here should be quotient rule. And quotient rule implies that you have vu prime minus vv prime over v squared. So what is v? This is v, this is our u. The v I have here is just z plus 1. And at the same time, u prime means differentiate 5x squared plus y squared. Remember to differentiate partially with respect to x. So that means my u prime is differentiate 5x squared. Yes, because I can differentiate 5x squared partially with respect to x, so it is possible. So I'll have 10x. But plus this y squared now, can you differentiate y squared partially with respect to x? Since there is no x to differentiate, this becomes 0. So do you understand that logic? Then followed by a negative sign, u is 5x squared, then plus y squared. So v prime gives us what? V prime is differentiate this down part. Differentiate z plus 1. Remember, partially with respect to x. Is there any x to differentiate here? No. Differentiate z plus 1. Is that not 0 plus 0? So everything gives us 0 here. Divided by v squared. And v is just z plus 1 all squared. So that's how it works. So trivially, this becomes 0. Whatever I have left now should be z plus 1. Then I have 10x, right? So now since I have z plus 1 then 10x here, this can easily cancel one of this, right? So whatever I have left now should be 10x divided by z plus 1. So this is my fx. This is my fx. So the next thing for us to do now is to try this out. Del y of that same function, 5x squared plus y squared over z plus 1. And this will trivially, this is trivially vu prime minus vv prime. What would that give us? V is z plus 1. Then u prime means differentiate 5x squared plus y squared partially with respect to y. So if I differentiate 5x squared partially with respect to y, that will give me 0. Plus differentiate this y squared partially with respect to y. That's 2y, because there's y to differentiate in this case. So divided by, I'll still have a negative sign. I need u v prime. U is 5x squared plus y squared. And then v prime is differentiate this thing partially with respect to y. There's no y to differentiate, and then it becomes 0. So all over v squared. So similarly, all this becomes 0. Whatever I have left now should be 2y of z plus 1. And z plus 1 will cancel one of this. I'll still have z plus 1 left here. So whatever I have left now should be 2y over z plus 1. So that is fy. Now what is fz? Fz means differentiate partially with respect to z of the function of x given to you. So z plus 1. So what will this give us? This simply implies that we have v prime. V is z plus 1. U prime means differentiate this thing partially with respect to z. This one differentiate partially with respect to z. No z to differentiate for this one, that's 0. Y square partially with respect to z. There's no way you can differentiate that, that's 0. Then minus, we need u. U is 5x square plus y square. Then u v prime. V prime is differentiate z plus 1 partially with respect to z. Differentiate z, that's possible, that's 1. Plus differentiate a constant, that's 0. No matter it is. So I will have over v squared. So it is clearly seen that 0 plus 0 is 0. This becomes 0. So I will end up having just negative of 5x squared plus y squared inside the bracket, then divided by what? Z plus 1 or squared. So this expression here gives me the result for fz. So we have fx now, we have fy, and at the same time we have fz. Now the main concept is, this f of x is depending on x, y, x comma y and comma z. So which x are you using, which y are you using, and which z are you using? We are using the initial one, which is x naught, y naught, and z naught. So x naught should be minus 2.0. So that means wherever I see x, I'll put minus 2.0. And for this, sorry, see it here. Anyway, I see y in this expression, like this y I have here now, I'll put 0.9. If I see z, I'll put 1. So that is just the pattern. So we are putting the initial guess that we have into this function so that we can easily get, I actually told you that this fx is not standing alone. The best way of writing this is fx open bracket x comma y, and that x comma y is the initial guess, the initial value that we always have, the initial point for x and y respectively, and this is the initial one we actually guessed for. So that means I have f of x open bracket x comma y comma z, where x is minus 2, y naught is 0.9, and z naught is 0, is 1 rather. So that means you have to put everything here. X is minus 2, z is 1, y is 0.9. So like that. So that's how it works. So the next thing for us to do from here now is I have to write this out. Dx is this. So dw rather. dw is, we have it as fx open bracket 0.02 plus fy minus 0.03 plus fz multiplied by 0.03. So we all have fx. Dw is equals to fx expression. We have it as 10x over. We have it as 10x all over z plus 1. Then times 0.02. Take note of that. Plus, what's fy? Fy is 2y over z plus 1, right? 2y, fy is 2y over z plus 1 times negative of 0.03. Finally, we have fz. Fz is this expression we have here, and that's the negative of 5x squared plus y squared inside the bracket divided by z plus 1 squared. Mind you, this is still multiplying 0.03. So this is what I was actually trying to explain. I said this x, where our initial x naught, y naught, and z naught, now our initial guess for the approximation was, we use we use minus 2.0, we have 0.9 and 1 respectively for this initial x naught, y naught, and then that means this x represent x naught, y naught, the initial z naught, and like that. So then we have dw, which is the total derivatives, to be equals to 10 times x is minus 2.0, right, divided by z is 1 plus 1 times 0.02, then plus 2, y is 0.9 for my initial guess, and I also have 1 plus 1 times minus 0.03. So you just have to substitute, and that's all. So here in this case, you do the same thing. 5 minus 2.0 squared plus y is 0.9 squared divided by 1 plus 1 squared, then times 0.03. So that's how it works. So then whatever we have to do from here now is to find the W. So I have to press this directly. I have a fraction. So I have 10, sorry, 10 open brackets minus 2.0. I have 1 plus 1 times 0.02. So next thing for us to do now is to um, add it with plus. Just have a fraction 2, 0.9, 1 plus 1 times minus 0.03. Finally, with a negative sign, plus times minus, plus minus, I have a fraction. I have 5 open brackets minus 2.0 squared, then plus 0.9 squared, close the bracket, then 1 plus 1 squared is almost filled up. I pray it's okay, it's contained. So that's all. Final answer. So the final result that I have for this in this case now is minus 0.383. So 3 decimal place, I have 0.383. Now, since we have the total derivative, the value for the total derivative to be equals to this. So remember that change in W from what we have initially should be equals to the approximate, the change in error should be equals to, remember that we said it is something similar to this. Change in z equals to f of x comma y, then plus dz. Here, f of x comma y here is just like saying f of x not y not. That's f of the initial, f of 3 comma 1. So our own initial guess is what we put here in this case. Then that will be um let's say f, yes, our own will be f of x not y not x and z not. That's the initial guess. The initial guess we used was, remember that it was okay, I think I still have it here. Okay, we have it at the back here. Oh, so the initial guess is minus 2.0, 0.9, f of minus 0, minus 2.0, 0.9 and 1. Remember that was our initial guess. And at the same time, remember that the formula is added with the final answer we have as our total derivative. That gives the approximate value, the correct accurate result, the accurate result for that approximate. So and mind it is not always equals to, it's always an approximated value. So how do you get f of minus 2.0, 0.9 and 1? So that's another thing entirely. So that's not an issue. You know, we call that f of x comma y comma z is the function given to us initially, and the function was given to us as 5x squared. It was given to us as 5x squared plus y squared over z plus 1. So that means f of minus 2.0 comma 0.9 comma 1 simply implies that wherever I see x, I'll put minus 2.0. Wherever I see y, I'll put 0.9. So to make that very, very easy to do, so this is a fraction, 5 alphabet x squared plus alphabet y squared. Then I can decide to use m as z plus 1. So I want to calculate when x is minus 2.0. It's asking for y. When y is 0.9 and z is what? 1. So my final answer is 10.405 to 3 decimal places. So I have my f of minus 2 of that initial guess to be 10.405. So just come here and say that, okay, the approximate for the expression given to us from the question should be this result, which is 10.405. plus the W that we have here. And the W is minus 0.383. So this gives the approximate for that expression, and that is 10.405 plus times minus is minus 0.383. Final answer, I have it as 10.022. So this gives the approximate. This is the approximate for that expression given to us in the question. So that's the correct answer is 10.022. But mind you, the solution I actually sent initially was, the mistake I did then was using x naught, y naught, z naught as the final. Uh, I actually used the final point for x, y, z in this case, which is not meant to be so. So I should have used the initial one. Okay, so please take note of that. Okay, thank you. Thanks for watching.